quickly look at equilibrium constants. Before then, let's take a short review on the law of mass action. What is the law of mass action trying to tell us? The law of mass action is the expression that shows the relative concentrations of the products and the reactants at the equilibrium point of a reversible reaction. The law of mass action introduces us to what we call the equilibrium constant. The law of mass action states that the equilibrium constant of a reversible reaction is the ratio of the concentration of the product to that of the reactant, each raised to its stoichiometric coefficient in the balanced equation. See what we mean mathematically. This is what the law of mass action is telling us. It is the law that defines the equilibrium constant of a reaction. Now note this, the equilibrium constant has the symbol K. You can call it KEQ. You can also call it KC. That is equilibrium constant with respect to concentration. Any of these can be used to replace equilibrium constant symbol. Now let's see what the law of mass action is saying. If we have a reaction which we can represent as A, whose number of mole in the balanced equation is symbolized with small letter A, reversibly giving us B, whose number of mole in the balanced equation is symbolized with small letter b. The equilibrium constant of this reaction, which is in equilibrium state, according to the law of mass action, states that equilibrium constant, KEQ, this is what we call equilibrium constant, that's the symbol, is equal to the concentration of the product divided by the concentration of the reactants, each raised to its stoichiometric coefficient. Now let us relate this formula to the equation given to us on the board. Now, according to the law of mass action, to write the equilibrium constant for this reaction, it will be equal to the concentration of my product, in which in this equation my product is B raised to the power of its stoichiometric coefficient, which is small letter b, divided by the reactants, which is the concentration of A raised to the power of its stoichiometric coefficient, which is A. Please note, in chemistry, the square brackets, this is used to denote concentration. Okay, so according to the law of mass action, the equilibrium constant for this equation on the board, for this balanced equation, is giving us equilibrium constant equal to the concentration of the product, which is the B, raised to its number of mole in the equation, divided by the concentration of the reactant, which is A, raised to the power of its stoichiometric coefficient, small letter A. In the next video, we'll be solving lots of examples on this using real chemical equations. Thank you. Do not forget to like our page, share our link with your friends, subscribe to our channel, and hit the notification button. Thank you.